Chapter 2 is an introduction to CoComposer Studio version 5.2. CoComposer Studio is an integrated development environment, or IDE, that combines the editing, debugging, and analysis tools into a single package. It's based on the Eclipse open source development tool. Before you can write code for the Stellaris LM4F, you need to get acquainted with the tool you'll be using. Stellaris devices are also supported by Mentor Graphics' Mentor Embedded IDE, IAR Systems' Embedded Workbench, and ARM's Kyle Microvision IDE. Stellaris microcontrollers are supported by 4 different integrated development environments. Mentor Graphics' Mentor Embedded Code Sorcery tools, IAR Systems' Embedded Workbench tools, the ARM Kyle Microvision tool, and Texas Instruments CoComposer Studio tool. You can see the eval kit licenses there. Some of them offer 30-day full function, some of them are code size limited. The CoComposer Studio version is full function, but it's onboard emulation limited. If you use and connect the Launchpad board to your computer, you have full function capability of CoComposer Studio. Only if you go off to use a target board do you need to actually buy the tool. For the compilers, you can see that some companies use the GNU tool, some of them use their own tool. TI has their own C++ compiler, although C++ is not supported on embedded microcontrollers because of the large sizes that it can generate. For the debugger IDE, 2 of the tools offer Eclipse-based support. Eclipse is the open source workbench tool that's been out there for quite some time. Full upgrade on these devices, on these tools, for the Mentor Embedded tool, $99 for the Personal Edition, $2,800 if you want full support. For the IAR Systems tool, about $2,700. For ARM Kyle, about $2,900. CoComposer Studio, the pricing is $445 for the downloadable version. If you want the CD, it's $495. Most of the companies offer JTAG debuggers, and there are also third-party debuggers out there. IAR Systems offers their JLink for about $300, ARM Kyle for about $200, and Texas Instruments has the XDS 100, an entry-level tool, for about $80. We also offer the 200 and the 500 that have additional capabilities at an additional cost. Stellaris microcontrollers are supported by 4 different integrated development environments. Mentor Graphics' Mentor Embedded Code Sorcery tools, IAR Systems' Embedded Workbench tools, the ARM Kyle Microvision tool, and Texas Instruments CoComposer Studio tool. You can see the eval kit licenses there. Some of them offer 30-day full function, some of them are code size limited. The CoComposer Studio version is full function, but it's onboard emulation limited. If you use and connect the Launchpad board to your computer, you have full function capability of CoComposer Studio. Only if you go off to use a target board do you need to actually buy the tool. For the compilers, you can see that some companies use the GNU tool, some of them use their own tool. TI has their own C++ compiler, although C++ is not supported on embedded microcontrollers because of the large sizes that it can generate. For the debugger IDE, 2 of the tools offer Eclipse-based support. Eclipse is the open source workbench tool that's been out there for quite some time. Full upgrade on these devices, on these tools, for the Mentor Embedded tool, $99 for the Personal Edition, $2,800 if you want full support. For the IAR Systems tool, about $2,700. For ARM Kyle, about $2,900. CoComposer Studio, the pricing is $445 for the downloadable version. If you want the CD, it's $495. Most of the companies offer JTAG debuggers, and there are also third-party debuggers out there. IAR Systems offers their JLink for about $300, ARM Kyle for about $200, And Texas Instruments has the XDS 100, an entry-level tool for about $80. We also offer the 200 and the 500 that have additional capabilities at an additional cost. So what is CoComposer Studio? CoComposer Studio is an integrated development environment, or IDE, for all of TI's embedded processors. That includes the debugger, the compiler, the editor, the simulator, any OS support that you require. The IDE is built on the Eclipse open source software framework, and it's been extended by Texas Instruments to support additional device capabilities. CoComposer Studio version 5 is based on off-the-shelf Eclipse. It's version 3.7 in CoComposer version 5.2. It's an unmodified version of Eclipse, and we contribute our changes directly to the open source community rather than just building it into our tool. So you can drop in Eclipse plugins from other vendors, or you can take TI tools and drop them into an existing Eclipse environment if you want to. So you, the user, can take advantage of all the latest improvements in the Eclipse tool. Of course, you can integrate additional tools, OS level application development like for Linux, Android, TI SysBIOS. Also code analysis, third-party code analysis, source control, those are all offered. CoComposer Studio runs under Windows and it runs under Linux. $445 for a single seat. It's a $99 a year subscription fee for maintenance. CoComposer Studio has two user interface modes. First is a simple mode. By default, CCS opens up in a simple basic mode. It's a simplified user interface to the standard Eclipse perspective with far fewer menu items and toolbar buttons. TI supplies these perspectives called CCS Edit and CCS Debug to the tool. If you want to, you can switch back to the advanced mode. That uses the default Eclipse perspective, which is similar to what existed earlier in CoComposer Studio version 4. If you are integrating other Eclipse-based tools into CoComposer Studio, that's the recommended way to go. If you want to switch modes, on the CoComposer menu bar, select Window, Open Perspective, Other. Check the Show All checkbox, as you can see in the Open Perspective dialog down below. The C/C++ and the debug that you see there, those are the advanced perspectives. Some common tasks that you might perform would be creating a new project. It's very simple to create a new project for the device using templates. Build options. We have simplified build options dialog from earlier CoComposer versions that basically exposed thousands of different options. Those options are still available, but they're in submenus, which makes this much easier to walk through the first time. Updates to those options are delivered with compiler releases, and they're not dependent on installing an entirely new version of CoComposer. If you want to share projects, it's easier for users to share projects, including working with version control and making sure that you have portable project. You can set up linked sources. Doing this has been very much simplified from earlier CoComposer versions. The Eclipse idea of workspaces and projects can be a little odd at first. Workspaces contain your settings and preferences for the way that Eclipse looks, as well as links to your projects. When you go in and you delete a project from the workspace, that deletes the links, not the files. Now, this is unless you have located or copied your files into the workspace, which is possible. In most cases, you just link your project into the workspace and preserve your project. So you can see, as you can see, you can have multiple projects in the workspace. You can make your settings and preferences and save those and export those. Your projects, when you work with a project contains your build and your tool settings, as well as the links to your input files. Deleting files from the workspace deletes the links, not the files. Again, unless you've located or copied files in the workspace. So you can see on the far right there are our source files, our code and data, our header files with our declarations and defines, and any of our library files which has code and data in them as well. The best practice way to do this is to link all of those into your project and then to link it into the workspace so that your original code is preserved for you, and when you delete any of these things, you don't actually delete the hard-worked code that you've achieved. New projects are created through the project wizard. And you can see the new project dialog on the left-hand side. So it's a single-page wizard for the majority of users. If you were to get to the bottom of this and rather than click the Finish button, you click the Next button, it would show up if you have a template that requires additional settings. In this case, this one does not. The debugger setup is all included. You choose the location, the device, and the connection for this. This will create a modifiable CCXML file in your project. The idea is that this is simple by default. The compiler version, the endianness, all these other advanced settings are all in the advanced settings area and not exposed right here. So you can see the project type at the top is, in this case, Lab 3. It's an executable project type. I've located it in this location. The family is ARM. The variant is the 120. That's the version that we're working with now. When you're in the labs, you just type into this variant space and it will bring up your parts out of a long list of Stellaris devices. So we've picked the LM4F 120 H5QR over there on the right. The connection type, if we're using the Launchpad or any of the other Stellaris boards, it's the Stellaris in-circuit debug interface. And you can see under the projects that we can pick empty project that has absolutely nothing in it, an empty project with a main.c already dropped in, assembly only, DSP BIOS, which is TI's real-time operating system, another type of project. You can also use some basic examples to start from if you like. So this creates the project for you, drops it in, and all you have to do is get started editing main.c. Once you've created a project, you'll probably want to add some additional files to the project. So you can see I've gone up in, I've right-clicked on my project, I've picked Add Files to Project. I can select multiple files if I like, rather than just one at a time. In this case, these files are going to support my activities in my project. So what is it that I want to do? Do I want to copy these files into my workspace? Or do I want to use these in multiple projects and just link them into my project as shown in the bottom window here? So in this case, I'm going to link to the files. Well, how do you want to link to them? Is this relative to where your project is located? Is it relative to where your tools are located? You can pick right out of here. So the Add Files to Project allows you to control how the file is added to the project. This is something you've probably never thought of in your integrated development environments that you've worked on in the past, but it's extremely important to know where those files are. Linking the files using the built-in macros allows you to easily create portable projects. In Lab 2, you'll start using CodeComposer Studio. Don't get bogged down trying to understand the code. You'll get to that in the next lab. Here, just concentrate on the tool itself. During the recording of this video, we'll be using a second monitor displaying the PDF of the workbook. We'll be using it for copying and pasting, but it will be off screen for the video capture you'll see here. If you have a second monitor, you may find it very useful during the workshop labs. In Lab 2, Step 1, double-click on the CodeComposer shortcut on your desktop to start CodeComposer Studio. When the Select the Workspace dialog appears, browse to your My Documents folder. In Windows XP and 7, that's a little bit different, as you can see in the step. Obviously, replace the username that you see here with your own username and click OK. The name of the workspace isn't critical, but let's use My Workspace LM4F 120. Make sure you don't check the Use This as the Default and Don't Ask Again checkbox. If at some point you accidentally check that box, that can be changed in CodeComposer Studio. The location of the workspace folder is not really important, but to keep your projects portable, you want to locate it outside the Stellarisware directory. So go ahead and click OK. At this point, if you haven't already licensed CodeComposer, you'll be asked to do so in the next few installation steps. When that happens, select Evaluation. As long as your PC is connected to the Launchpad board, CodeComposer will have full functionality free of charge. You can go back and change the license if you need to by clicking Help, Co-Composer Studio Licensing Information, Upgrade tab, Launch License Setup. When the TI Resource Explorer and/or the Grace windows appear, close their tabs. At this time, those tools only support the MSP 430. In Step 2, we'll create the Lab 2 project. Make sure Co-Composer is maximized. On the CCS menu bar, select File, New, CCS Project, and then make the selections shown below in your workbook. That's project name of Lab 2, the output type is executable, uncheck the Use Default Location checkbox, and make the location C:\Stellarisware, Boards, My Launchpad Board, Lab 2, CCS. This step is important to making your project portable and in order for the links that we're going to use later in the class to work correctly. Select ARM in the Family window. If you don't see ARM, you have not correctly installed Co-Composer. Where the variant window is, just type in 120 and you'll see all 4 different types of the LM4F 120. Select the H5QR at the bottom. In the Connection window, select Stellaris In-Circuit Debug Interface, and then make sure at the bottom, under the project templates and examples, that you select Empty Project with main.c and click Finish. In Step 3, the main.c file will open up in the Editor tab. Delete the contents and type or copy and paste the code that you see in Step 3 into the file. Don't worry about exactly what's going on in the code now. We're going to go over this in detail in Lab 3. Now, in case you missed it earlier in the steps, we are using a second monitor here to copy and paste the code snippets from the PDF file. If you have a second monitor, it will make your life a lot easier in doing the workbook steps. If the indentation in your code doesn't quite look right, press Control-A on your keyboard to select all of the code. Then right-click on the selected code and then select Source Correct Indentation. Click the Save button on the menu bar to save your work. If you're having any problems, you can find this code in your Lab 2 CCS folder in File main.txt. In Step 4, expand the project in the Project Explorer pane. That's the one on the left side of your screen, by clicking the plus next to Lab 2. This list shows all the files that are used to build the project. One of those files is startup under ccs.c that we included in your lab folder. This file is available in every Stellarisware example. Double-click on the file to open it for editing. This file defines the stack and the interrupt vector table structure, among other things. These settings are essential for Co-Composer to build your project. Close the editor window when you're done looking at the file by clicking on the X in the tab at the top of the editor window. Do not save any changes if you accidentally make any. In Step 5, we're going to set the build options. Basically, this is going to tell Co-Composer where to find the rest of the header files and other pieces that it needs. If you look at the top of your window in main.c, you'll notice that there's question marks to the left of the include files. That means Co-Composer has no idea where to find them. We're going to tell it. In Step 5, right-click on Lab 2 in the Project Explorer pane and select Properties. Click Include Options under ARM Compiler. In the bottom Include Search Path pane, click the Add button and then add the following include search path. And and you may want to copy and paste this from the workbook PDF for the next 2 steps. What this path does is it allows the compiler to correctly find the driver lib folder, which is 4 levels up from your project folder. Note that if you did not place your project in the correct location, this link will not work. Click OK. In step 6, under the ARM linker, click File Search Path. Add the following include library file to the top window. Again, this step allows the linker to correctly find the library file. Again, if you did not place your project in the correct location, this link won't work either. Click OK to save your changes. So click OK. Make sure that your Launchpad board is plugged in. Check that Lab 2 is the active project by clicking on the project in the Project Explorer pane. Click the Debug button on the CCS menu bar to build and download the Lab 2 project. When the process completes, CodeComposer Studio will be in the debug perspective. Note the 2 tabs in the upper right of your screen. You'll notice on ours that you can't quite see the CCS debug tab. So if you drag them to the left by reaching over on the left-hand side of the leftmost tab, right there, drag it, then you can see both of them. You can create as many additional perspectives as you like for your specific needs. Only the debug and edit perspectives are predefined. In step 8, click the Run button on the CodeComposer menu bar to run the code. Observe the tricolor LED blinking red, green, and blue on your Launchpad board. In Lab Step 9, click the Suspend button on the CCS menu bar. If the code stops with a No Source Available indication, click on the Main.c tab. Most of the time in the while loop is spent inside the delay function, and that source file is not linked into this project. In the code window in the middle of your screen, double-click in the gray area to the left of the line number in the GPIO pin write instruction to set a breakpoint. You can also right-click on the instruction and say toggle breakpoint. When you set that breakpoint, click the Resume button to restart the code. The program will stop at the breakpoint, and you'll see an arrow to the left of the line number indicating that the program counter has stopped on this line of code. You should note that the current in-circuit debug interface driver, the ICDI driver, does not support adding and removing breakpoints while the processor is running. Click the Resume button a few times or press the F8 key to run the code. Observe the LED on the Launchpad board as you do this, and you'll see it change from red to blue to green and back to red. When you've done that a few times, remove all the breakpoints you've set at once by clicking Run, Remove All Breakpoints from the menu bar. Again, breakpoints can only be removed when the processor isn't running. In step 10, click on View Registers to see the core and peripheral register values. Resize the window if necessary. Click on the plus sign on the left to view the registers. Note that any non-system peripherals that have not been enabled cannot be read. In this project, you can view the core registers, the GPIO port F, that's where the LEDs are located, the HIBE, the flash control, the sys control, and the NVIC. So we can expand all of those. This might be a good time to mention, and here especially, we've changed the perspective pretty drastically. To easily get back to the default perspective, you can click Window, Reset Perspective, and say yes. This also applies if you do something like getting rid of the debug window. If you accidentally click the debug window, now your debug tools go away. This is easily remedied by clicking View, Debug. although you could have just as easily reset the perspective. In step 11, click on the View Memory Browser to examine the processor memory. Type 0x00 in the entry box and press Enter. You can page through memory, and you can click on a location to directly change the value in memory. In this case, don't click on anything to change it because we don't know what we're doing at this point. In step 12, double-click on the variable LED in the code window around line 18. Right-click on the selected variable and select Add Watch Expression, and then click OK. The window on the upper right will switch to the expression view, and you should see the variable listed. It might report identifier not found if your code was running. When you halt the code, the watch window would update. Click on Terminate to return to the editor perspective. Right-click on Lab 2 in the Project Explorer pane and click Close Project to close the project. Minimize CodeComposer Studio. In step 14, the LM Flash Programmer is a standalone programming graphic user interface that allows you to program the flash of a Stellaris device through multiple ports, serial, Ethernet, the JTAG port. Creating the files required to do this is a separate build step in CodeComposer that's shown on the next page. If you have not done so already, make sure you install the LM Flash Programmer onto your PC. In step 15, make sure that CodeComposer Studio is not actively running code in the CCS debug perspective. Otherwise, CodeComposer and the Flash Programmer will conflict for control of the USB port. You'll probably see a LM Flash Programmer link on your desktop. Double-click on it to open the tool. If that shortcut doesn't appear, you can go to Start, All Programs, Texas Instruments, Stellaris, LM Flash Programmer, and click on LM Flash Programmer. In step 16, your evaluation board should currently be running the Lab 2 application. If the user LED isn't blinking yet, we'll press the reset button on the board. We're going to program the original application back into the LM4F 120 H5QR. Click the Configuration tab and select your evaluation board. If you don't find the LM4F 120 XL evaluation board in there, use the LM4F 232 evaluation selection. In step 17, click on the Program tab, then click on the Browse button to navigate to /Stellarisware /boards /EK LM4F 120XL /QS RGB CCS debug, and you'll find in there QS RGB.bin. This is the application that was programmed into the flash memory of the LM4F 120XL during the evaluation board assembly process. Note that there are applications here which have been built with each supported IDE. Make sure that the following checkboxes are selected here: the Verify After Program and the Reset MCU After Program. When that's done, click the Program button. You should see the programming and verification status at the bottom of the window. After these steps are complete, the Quick Start application should be running on your evaluation kit, and you can see that it is. In step 19, go ahead and close the LM Flash Programmer.